dielectric loss. Absorption of electrical energy by electric material when subjected to AC supply is called as a dielectric loss. The absorption of electrical energy by electric material. So absorption of absorption of electrical energy by absorption of electrical energy by dielectric material absorption of electrical energy by dielectrical material when subjected to AC supply. When subjected to AC supply, is called as dielectric loss. It's called as dielectric loss. Okay, this is our dielectric loss when electrical energy is absorbed by who absorbs the electrical energy? Dielectrical material. Dielectrical material absorbs the electrical energy when it is subjected to AC supply. With whom? With AC supply. When electrical energy is absorbed by electrical material when subjected to AC supply, it's called as a dielectric loss. It is a dielectric loss. An ideal dielectric loss does not absorb any electrical energy. Okay, this is a practical absorption of electrical energy by dielectric loss. But in case of ideal dielectric, no energy absorbed by this dielectric material. An ideal dielectric does not absorb any electrical energy. Okay, the real dielectric material always causes some loss of electrical energy. So here I draw two diagrams. This is ideal. This is for the ideal and this is for the practical. Okay. In case of practical, always there is one internal resistance is present, and this internal resistance present internal resistance absorb the electrical energy. But in case of ideal, there is no any internal resistance present, so no any energy is absorbed by dielectric material. Okay, no any electrical energy is absorbed by the dielectrical material. Okay, this is a lossy dielectric and this is a equivalent circuit of lossy dielectric circuit. Okay, so now we draw here a phasor diagram. Now we draw here phasor diagram. Phasor diagram is ID versus IR. This is our IR and this is ID. And this is R, and the equivalent is our total current I. Which makes angle phi with IR and the mixed angle with ID is delta. What is the angle? Delta equals to 90 minus phi. delta equals to 90 minus square. Angle delta equals to 90 minus 5. Okay, this is the phasor diagram. Okay, what is dielectric loss? The absorption of electrical energy by electrical material when subjected to AC supply is called as dielectric loss. Okay, so now we have to derive a small derivation for dielectric loss. Consider a parallel plate capacitor. We have to consider one parallel plate capacitor. Consider parallel plate capacitor. Consider parallel plate capacitor. And we have to consider one parallel plate capacitor having plate area AM square. Okay, having plate area of plate is, consider parallel plate capacitor. Consider parallel plate capacitor having working area equals to A in meter square. That means AM square, having the working area AM square, and separated by distance D. Separated by distance equals to D in meter. Okay, separated by a distance D, separated by distance D in meter, separated by distance D in meter. After that, let the dielectric having permittivity means that is epsilon r. Okay, permittivity is the epsilon r, be filled between the plates. Okay, that means dielectric material is filled in parallel plate is the permittivity of this filled material is, dielectric material is epsilon r. Permittivity of parallel plate is epsilon r. Then I equals to ID plus J of IR plus J of ID. Okay, then I equals to IR plus J of ID. Then we know that IR is V upon IR. Okay, V upon R by the Ohm's law, plus J of omega upon ID equals to J of omega upon 1 upon CV. 1 upon CV. Okay, 1 upon CV, that is Q equals to CV. 1 upon CV. Therefore, by simplifying this equation, we will get I equals to V upon R plus J of omega CV. J of omega CV. This is our I. Therefore, I equals to V upon R plus J of omega CV. Then what is this IR and what is this ID? What is the meaning of IR and what is the meaning of ID? IR is the conducting current. What is IR? IR is a conducting current and ID is the displacement current. Okay, very simple. IR is the conducting current and ID is the displacement current. Okay, IR is the conducting current and ID is the displacement current. Okay, in case of lossy dielectric, we before some time we draw here a lossy circuit which contains only AC supply with one capacitor. This is called a lossy circuit. In case of lossy circuit, that is which contains a parallel plate capacitor, okay, which contains parallel capacitor, and this is the ideal. In this case, no any dielectric losses absorbed or no any dielectric losses appears in case of logic circuit. But in case of a practical, uh, uh, in case of practical, there is a one internal resistance is present, because of that dielectric losses happen in case of a parallel circuits. Okay. In case of ideal capacitor, the value of R is infinity. In case of ideal capacitor, the value of the R is infinity. That means IR equals to 0. That means IR equals to 0. Okay, that means IR equals to 0. So it won't not absorb any dielectrical energy, and hence resultant current is I equals to ID. Resultant current I equals to ID in case of ideal in case of lossy circuit, or ideal circuit. Then in case of practical, what we have observed there, in case of practical, there is a one internal resistance is present, but in case of ideal, there is no any internal resistance is present. That is R, value of the R is infinity, so IR equals to 0. If the value of IR is 0, then total current I equals to ID. Then total current I equals to ID. Then after that, the phasor angle. By using phasor diagram, we can define that the angle delta equals to 90 minus phi. Angle delta equals to 90 minus phi, and this angle is called as, this delta is called as dielectric loss angle. This delta is called as dielectric loss angle. Okay, what is my delta? Delta is the dielectric loss angle. Okay, delta is the dielectric loss angle. For ideal transformer, the value of phi is always equals to 90 degree. Okay, in case of ideal transformer, the value of angle phi is 90 degree. Then delta equals to, we know the formula for the delta. Delta is equals to 90 minus phi, and in case of ideal lossy circuit, or in case of ideal circuit, the value of the phi is 90 degree. Therefore, 90 minus 90, then delta equals to 0 in case of ideal circuit. The value of delta is 0. Now, what is my delta? Delta is the dielectric loss angle. Okay, what is delta? Delta is the dielectric loss angle. That means in case of ideal circuit, the dielectric loss angle is 0 and the internal resistance is infinity. Okay, clearly. Then what is the value of tan delta? What is the value of tan delta? Then tan delta is the, what is the value of tan delta? Tan delta, what is the value of tan delta? Tan delta is IR upon ID. IR upon ID is the value of tan, delta, or it is called a loss tangent. Okay, tan delta is called as loss tangent. Okay, tan delta is the loss tangent. Then dielectric loss is given by P equals to V into I into cos phi. P equals to V into I into cos of phi. This is the dielectrical loss. Then what is the value of phi? Value of phi is V into I into cos of 90 minus phi. 90 minus phi. Sorry, 90 minus delta. V equals to cos of 90 minus delta, and we know that the 90 minus delta is nothing but the Vi sine delta. Okay, Vi sine delta. This is our equation of P. Then P equals to V into I into sine delta. From the phasor diagram, cos of delta is ID upon R. From the phasor diagram, cos of delta equals to ID upon I. Okay, by using the phasor diagram, cos delta equals to ID upon I. Therefore I equals to, by rearranging this equation we will get ID upon cos of delta. Okay, then P equals to P equals to cos of P equals to Vi sin phi, then cos delta equals to ID upon I, then I equals to ID upon cos phi. Okay, this is our equation for the I. Putting equation 3 in equation 1, that means put the value of I in value of P equation. Put this value in P equation, power equation. Then we will get P equals to V into ID upon cos delta, into sine delta. By rearranging this, V into ID into sine delta upon cos delta. Then what is sine delta upon cos delta? Is nothing but the tan delta. Then P equals to V into ID into tan delta. But tan delta is IR upon ID, right? But tan delta is IR upon ID. Then ID equals to V upon XC. Then ID equals to V upon XC. Then put the value of ID is V upon XC into tan delta. That means what is XC? Value of XC is 1 upon 2 pi FC. Capacitive reactance equals to 1 upon 2 pi FC. Therefore, put this value of XC. By putting XC equals to 1 upon 2 pi FC, we will get P equals to V square. V into V is the V square upon 1 upon 2 pi FC. 1 upon 2 pi FC. If we rearrange this equation, we will get final equation P equals to 2 into pi FC into V square, into right here equation. Final equation of P is V square 2 into pi FC into V square into tan delta equals to tan delta, where V is applied AC voltage. Here V is applied voltage, that is the square of applied voltage. Okay, square of applied voltage. Delta is the dielectric loss angle. Delta is dielectric loss angle. P is the dielectric loss. Okay, P is our dielectric loss and C is capacitance of the parallel plate capacitor. Okay, got it? This is the small derivation of dielectric loss. So from above equation, from above equation, it is clear that dielectric power loss in dielectric power loss in dielectric is directly proportional to the frequency. That means it is directly proportional to the frequency. So the frequency is very important to calculate the dielectric loss. Okay, this is our dielectric loss. I hope you understand this topic. Here what we observe, we consider a parallel plate capacitor. We consider here a parallel plate capacitor having capacitance of C. Consider a parallel plate capacitor having capacitance of C, and the area of parallel plate capacitor is Am square, and this parallel plate capacitor, the plates of capacitor are separated by a distance d in meter square meter. Okay, after that we consider the permittivity of permittivity field in parallel plate capacitor is mu r. Okay, then the total current I equals to IR plus J of ID. IR is the conducting current and ID is the displacement current. Okay, then total current I equals to conducting current plus J of displacement current. Okay, then in case of ideal ideal or lossy dielectric circuit, in case of ideal or lossy dielectric circuit, the resistance R is infinity, so that the internal so that the IR is the conducting current is that means conducting current is 0. That means no any current is flowing through that circuit, so it will not absorb any dielectrical energy, and hence the resultant current I equals to only ID, because IR is the value of IR is 0. Therefore, I is equals to ID. But for the ideal capacitor, phi is always 90 degrees, so value of the delta is also 0. Therefore, the angle delta is equal to 90 minus phi is called the dielectric loss angle. Okay, this is our dielectric loss angle. Then tan delta equals to ID upon R. That is a loss tangent. It is called as a loss tangent. Tan delta is called as a loss tangent, and the value of tan delta is IR upon ID. Then the dielectric loss is given by P equals to V into I into cos phi. But we know the value of cos phi, value of the phi is 90 minus delta. Therefore, P equals to V into I into sin delta. Cos 90 minus delta is always sin delta. Therefore, P is equals to V into I into sin delta. Then cos of phi equals to, from the Phasor diagram, cos of phi equals to ID upon I. Therefore, by rearranging this, we will get I equals to ID upon cos phi. Therefore, put this value of I in the equation of dielectric loss P equation. Therefore, we will get P equals to V into ID upon cos of delta into sin delta. By rearranging this equation, we will get P equal to V into ID into tan delta. Okay, and now here we have to put the value of ID, that is ID is displacement current, is equal to V upon XC, and XC is our inductive capacitance. The value of inductive capacitance is 1 upon 2 pi FC. Therefore, by putting this value of ID, putting this value of I in equation, we will get finally P equals to 2 pi FC V square tan delta. Okay. Okay, I hope you understand